Hello everyone. So today this is 8th week of the course Plastic Waste Management offered by IIT Kharagpur as a part of Swayam courses. And in this week, we will be actually mostly focusing on this life cycle analysis. And I will be presenting my slides. Wait. So let me just present it. Yes, entire screen share. So what I think it's there. Yes, just present the slide. Yes, so let's make the screen. So today in this particular week, today I will be discussing questions related to the week 8 of the course plastic waste management, and I will be discussing somewhat about the micro nanoplastic along with that, because this micro nanoplastics are nothing but the integral part of the overall plastic waste which is happening, and improper management of them, and how potentially they are more uh, dangerous as compared to the regular bigger chunk of the plastic, right? And these are some of the questions, around 15 questions we will be solving. uh, and I will be discussing one question that has been asked in last class. That there was a confusion of one student in the in the in a particular slide of this resin identification code discussed in the week 1 and in the 6th week slide of the lecture. So I will be discussing the same, uh, and then we will be solving the question, right? And along with that, I will be discussing somewhat concepts that has been taught in this particular week, which is week 8, uh, where this plastic resource recovery and circular economy, right? So here, mostly how this concept of circular economy comes into plastic and circular economy, and how this plastic resource recovery happens, that we will be discussing what is this life cycle analysis and everything. So so how from the production to fabrication to use with end life, and then the recycling process, where this recycling happens to manufacturing plastic resins, and then for our monomer processing, if you can actually convert that or recycle that to the initial specialty chemicals. And another one is this I mean this recycle this one, which is a recycling them, landfill at the end, or reusing them if possible, right? And recovery, energy recovery also is the another thing that can be done. So this waste management hierarchy, which is this what is the most preferred and what is the least preferred one. So if you see, this landfilling is the least preferred one option, and it is the last option if you could not do anything, any economical thing, or any preferential thing, like for example, mostly with the thermostats this problem arises, right? So source reduction, the reuse, the recycling, resource recovery, incineration, and then landfilling. So these are waste disposals method: resource recovery, incineration, and landfilling, right? So if you see this one, the plastic waste recycling value chain, where this loss to other waste stream and energy, right? Environment. So here how everything is starting. The step one is consumer, from where the waste produces, right? And then this is this second, where this handling of the waste is come. So sometimes you will be losing loss to export or incineration, and something is this sorting. So in the sorting, you see that after that there will be recycling compounders. So there this rejects which is not fit for recycling, that will be rejected, right? And mostly these products which are there, they will go for the another way of managing the plastic waste, right? So this recycling compounders go to the producer, where this import of the virgin plastic will be also incorporated, incorporated with the recycled one, and then there is a design which will be used with the plastic consuming companies, right? So the pellets will be used, right? And then there is here in this cycle there is the production of waste, and some of the waste will be again put for the recycling if possible. If not, then that will be again discarded, and this cycle goes on, right? So this is something which comes as the integral part of this circular economy. So circular economy and sustainability, it's somewhat related in some sense, but there is two type of economies that has been discussed in the week, is linear economy and the circular economy. So if and one video was also there, in the linear economy you actually don't bother about the I mean, let me just allow let me just allow yes, Arukya is here. So I have started discussing like somewhat content of the week 8. So in this particular week of the course plastic waste management, mostly the discussion was on this circular economy and then this life cycle analysis, and how this sustainability, circular economy and life cycle analysis of the plastic waste will be related with each other. So I will be mostly discussing these questions which is related to the week 8 content, and then I will be discussing a doubt which has been asked in last class by one of the students, so that this will be, even the student is not there, this is recorded and he or she can actually go through this before the examination. So before that, it's like just the recap of the content. So these live sessions are basically for revisiting the contents very rapidly in order to have one revision kind of thing, and then there is some quiz kind of question that we will be doing, so that the assignment solving and the problem solving will be helpful, and the similar kind of questions you will be somewhere down the line getting it in the exams, right? So if you see this, so right from the first slide you see we are discussing this plastic resource recovery, where this plastic and circular economy is being discussed, where this the main thing is end of the life, which is the life cycle analysis, where what happens to that. In order to track that, there has to be data, right? So in that you saw that these are this incineration, landfilling and resource recovery, these are some waste disposal techniques which are least preferred, and the most preferred one is recycle, reuse and source reductions, right? So in this one, this is the concept of circular economy, where you are trying to recycle most of the waste that is coming directly or indirectly into the environment, right? Let me just make it half so that I can see both the screen, and just make it half. Yes. So yes. So the next one is this, where this material component and the products which are here. There is this design, something is designed, then acquisition of the material, engineering methods and tools, and the quality control, distribution, and then use, reuse, end use, recovery of the mass, quality control, redistribution. So everywhere this circular thing, economy, circular circulation of this entire tracking of the life of the plastic that is being used from the beginning to the end. For some it's like a very small cycle of the time, and for some type of plastics it's a longer duration. Okay, so this diagram also represents this environmental, economic, technical and the social aspects together, where and the central region shows this complex value optimization for resource recovery, where this sustainability assessment methodology and the life cycle sustainability analysis, which is LCSA, uh, and this life cycle costing, which is LCC, which is for the economic. So you see everything has to be considered if the overall sustainability you are looking at, where this environment, economics, technical, and the social aspects are each will be given preference in the at the level of implementation, right? So here, this economic strategies for recovery and the recycling of this plastics. If you see this lower energy requirement during input production, right? And then this high demand for the material in manufacturing, the cost of the alternative acceptable forms of disposable compared to the recycling, and the price of the virgin polymer compared to the recycled polymer. So if the recycled polymer is costlier than the virgin one, then the problem comes into the picture. So that's why this if this recycling is profitable at the end, the product which you are getting after the recycling is having similar kind of strength or the material property, but and is actually adding to the profit of some institution, then only they will be actually going for this. And if not, there has to be lots of support which has to be given to the government side in order to encourage that, so that there is some some benefits given to the producers, so that this process they do, the recycling they do, not just the production that they are doing, right? So environmental strategies for the recovery and recycling, where these enforcements of producers responsibility regulation that we have discussed many times for this plastic waste, enforcement of the nationwide law, uh, there is this enforcement of the environmental awareness, waste and segregation, and then creation of quality standard and certification schemes for plastic recyclers, so that there is some competitive kind of thing, so that the people follow it rigorously in order to achieve the goal, right? So the entire week mostly this has been discussed, and we will be having some questions on the same, right? So next week, what the similar concept was there. I think the continuation of the same was there, and this. Yes. So if you see, we will be going for the next slide. So in the week 2, this plastic resource recovery and introduction to the circular economy happened, and where this the technical metrics you use for this resource recovery. So whatever resource, whatever waste that you are having, you want to recover that. So what are the possibilities that you will be actually going for? Is this reusability, whether the final good that you want to recycle or that you want to reuse, so can you reuse it, or can you remanufacture a shareability, mass recyclability, and technical recyclability? So this slide becomes important for the exams. So difference between this, so there could be some match the column kind of thing, where this short definition of each will be there. For example, for this reusability, this amount of material that retains its functionality and physical attributes after the end of their primary life, okay, uh, for resource recovery, right? And then this remanufacturing is what potential to restore a component product to like new conditions through measuring, disassembly, cleaning, inspection, and sorting. Okay, so that can be reused for reassembling and final testing on a weight or item basis, right? And this Technical recyclability is a portion of the material or component made up of only one material collected from recycling that will be recycled for producing high quality recycled material, right? So this there is another terminology for the resource recovery. There is this mass recoverability, energy recoverability, technical recoverability, and component and the products have done this technological advancement. What is circular economy? This is the slide where this came into the picture, and entire next three lectures this was there till the end of the course, where this circular economy, what does it mean? It's an alternative to traditional linear economy. Make, use, and dispose were the main agenda points for that, in which we keep resource in use for as long as possible, extract the maximum value from them is in use, then recover and regenerate products and materials at the end of each service life, right? Okay, so if you see, uh, circular economy is restorative and regenerative by design. This means that material constantly flow around a closed loop system rather than being used once and then discarded. That was the part of the linear economy, right? Here you are not discarding, rather here you are trying to get maximum out of it, right? And now if you see this, as a result, the value of material is not lost by being thrown away. In the case of plastic, this means simultaneously keeping the value of plastics in the economy without leaking into the natural environment. So you are actually managing the plastic waste, right? That is the clear-cut goal of the circular economy. So you see the circular economy here is this. We can expand this particular slide, this one particular corner rather. So if you see here, this circular economy is what? Where this whomsoever designs and manufactures, it will go to the retailers, it will go to the consumer and household like us, and it will be then reused, repaired, and recycled. And this recycling sector will be actually giving the recycled plastic back to the design manufacturer, so that again the product will be formed and this distribution will be happening through the retailer to the consumer, and this cycle goes on, right? So that is the agenda. Okay, so here you see this circular economy thing. So circular economy here, recycle, design, production, the similar graph that we have just discussed. Here the residue waste will be there, that will be going for the last two or three options, which was landfilling, incineration, and this resource recovery, right? So one video was discussed where this linear to the circular economy, and this diagram becomes very important. So what I have outlined of the circular economy. So this I will be discussing again because this has been emphasized many times in the lecture. So here you see this is Alan MacArthur founders classification for this circular economy, which is very important. This is widely accepted, and you may expect some questions around this, right? So if you see here, one, two, three parts are there. So first one is what? If you see, the first one is this principle. So what is the principle? Preserve and enhance natural capital by controlling finite stocks and balancing renewable resource flows. Resolve, levers, regenerate, virtualize, and exchange, right? So renewables, flow management, stock management two places are there, and you see this here, whatever consumer is this side, collection is this side. So stock management has to be there and minimize systematic leakage and negative externalities, right? Hunting and fishing can take both post harvest and post consumer waste as an input. So this is the Ellen MacArthur Foundation. Okay, so it's like business and environment related thing. Center for Business and Environment vacancy. So here the third principle is foster systems effectiveness by revealing and designing out negative externalities, all resolve levers, right? And second one was this optimize resource yields by circulating products, components, and materials in use at the highest utility at all time in both tactical and biological cycles. Means this resolve levers is what regenerate, say, optimize loop. Here, regenerate, virtualize, and exchange was there. All resolve levers were there in this one. Okay, so it is actually considering both environment as well as energy, as well as society, as well as economy. So all the three, four aspects has been considered over here. Circular economic solutions in plastic sector is what how this solution will come. So suppose fossil fuel is there. So this fossil fuel, using that you have redesigned plastic production and products, right? So there could be another alternative such as renewable alternative sources is what this you can design using that. Okay. Now this production of only essential plastic using renewable resources mostly, so that are not harmful, right? This is one of the solutions. Then consumer use based on sustainable business model. So whatever is sustainable, there will be business. Some will be going for the energy recovery, coming back to the plant for the energy requirement, and then some will be leaking. And as this leakage will be mostly coming because of the renewable electricity sources, there is less problem to the ecosystem as compared to the one which is coming from the usual synthetic plastics that is mostly spreading across the world and in India, right? So here, if you see, there is this reuse through models such as refurbishing, sharing, leasing, redistributing, and symbiosing. This, right? And the last one is this recycling, including through remanufacturing, chemical recycling, organic recycling, and conversion to new products, right? So now from the recycling, also you can go for this. Whatever product is coming after recycling, it will again go to the production of only essential plastics using renewable resource, right? So, and also from here you can go for this product design, plastic production, and this and products whatever is coming out, right? So this is the solution slide for which is actually following the circular economy. And what is the challenge with this is the kind of strength that is mostly required for lots of industrial activity or the purposes that we are having now is the quality of the plastic that is required for some work that property is not met by the one which is being coming from the renewable alternative resources, or if it is coming, the cost of that is very high. So that are the some of the challenges that is get to be sorted, right? And the last slide was again on this plastic in circular economy, where this plastic in the circular economy use collection mostly the similar thing was there, where you are actually looking at the environment, you are looking at the energy, you are looking at the social impacts, and then you are actually taking care of this overall economy and sustainability, right? The third lecture of the week was again the circular economy, but with more deeper sense, where this concept of this raw material which will be recovered and recycled and used, consumed, and the resource recovery and the waste management will be happening again, right? So you will see these are some objectives of the circular economy. These are some economic solutions in the plastic sector. Information platform is needed. Then produce plastic from alternative feedstock has to be there. There is this plastic waste as a resource. There is this plastic manufacturing processes and processed products to improve longevity, reusability, and waste prevention. And then increasing collaborations between business and consumers to increase awareness on the plastic recycling and reusing and abandoning the through agriculture, right? So why is circular economy important? Why? Because it will reduce the waste, it drive greater resource productivity, and then it will deliver a more competitive economy, and then it will position the world to the better addressing emerging and resource security scarcity, right? So issue in the futures, it will address those issues. Then it will help reduce the environmental impacts of our production and consumption in the world, right? So that is the one thing that has to be thoroughly sorted, right? And now let me just see if I can actually look. We will be actually solving, just it's just 30 minutes. We will be just looking at all the slide and we will be going for the discussions. So these were some case studies that has been discussed. So the company Unilever, right? They also came into the part for to follow the circular economy, and there are some steps that has been taken. So there is no business can create a circular economy for plastic packaging in isolation. Okay, so a circular economy has to be created. There they are working in 5 broad interdependent areas to achieve this change. First is rethinking how they design their product. Second is driving systematic change in the circular thinking at an industry level. Third is working with the government to create an environment that enables the creation of circular economy, including the necessary infrastructure to collect and recycle the material, right? Unilever steps towards the circular economy is this: working with the consumers in areas such as recycling to ensure they are clear on different disposable methods, recycling labeling in the US, labels in the US, and collection facilities such as Waste Bank in Indonesia, right? So these are some. Let me just see if somebody join. We just allow them admit. These are there are different case studies that have been discussed. So on these case studies also you may expect some question, and some questions you may expect if something happened, like this course has been recorded in 18, afterwards till 2025 there are some changes, there are some reforms that has been taken place. So very broad reforms, or like some companies that took part recently, recent newses around that also, 1 or 2 questions you may expect, but the most of the question will be from the slides itself. Just the 20% part can be somewhat from this course material that is being shared, other than the slides, and then the 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 new reforms that is actually there. Okay, Unilever steps towards a circular economy where this rethinking how they design their packaging, where they are actually looking at this, reducing the use of the material, using more recycled content, and then ensuring the packaging is recyclable or compostable, right? So like now the companies are also they started thinking about this, that there is a problem, and that has to be taken care at the source level only, right? So these are the Unilever one has been discussed very thoroughly. So there is the rethinking how they design the packaging. So the detailed discussion of that was there. Then rethinking how this one mostly about the Unilever entire one lecture, around one lecture was there. Complete discussion on Unilever's changes that they have actually incorporated. So I will be actually again looking at what this there is this exploration of radicals and innovative approaches. What they are actually looking at, they are having these new business models and innovations using circular economic principles are transforming traditional take, make, dispose thinking with incredible speed. Unilever want to be part of circular economy revolution, and they are committed to pioneer this breakthroughs in packaging waste. Unilever is also committed to breakthroughs that are needed if they are to move towards a circular economy. In doing so, unlocking the economic price for businesses, right? So there is this collection and sorting recyclable material plays an important part in the ensuring they can be used. So mostly NGOs. So they are promoting the NGOs also. There is this incentivizing behavior change is a big part of inspiring lifelong recycling habit. So consumers are offered discounts that they are giving. That is a kind of benefit to encourage them to bring their waste packaging to the government recycling points that they are having, right? So but only one company is going for that. So more of such steps has to be there in order to actually fulfill the requirement of the strength or the capacity of waste that is being produced in India right now, right? So the extended producer's responsibility, it has to be implemented more strictly or more strictly uh, than it is now presently acting. So this producers has to be made responsible, and they should do lots of awareness sessions and teach the awareness. Like there will be lots of ads coming up from the side of the company producers to buy their product, but there is nothing like the awareness kind of thing that will be actually teaching how to handle the end of the part of their product. Suppose the wrapper of their product or the wrapper of like packets of their thing. So that awareness has to be there. People are not taking care of that, and at the end it is the one which is actually becoming the culprit, right? So recycling waste value chain, what is that? Waste, then there is collection, there is the sorting based on different codes. I will be discussing about code today again. And then this uh, recycling recycling, and then this secondary raw materials which are coming up, right? So recycling rate of various drink containers, there is this. And you see in this one, the 74% of the consumer plastic drink bottles, 70% of the consumer glass drink bottle, 70% of the consumer with aluminum drink case, and then 70% of consumers type steel drink can, and rest is the 37% of cartoons, cartoon kind of this. So 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 this is this rate of recycling, okay. And the last one is this plastic and circular economy case studies continued. So where this CO2 emission saving yearly of this 14 lakhs tons, right? That much greenhouse gases, part of greenhouse gases are being saved using this recyclability or this energy conversion of the waste. So it is actually helping in improving quality of mechanical. So overall, this recycling is actually helping the nation, right? Better product design. So there are this making plastic recycle faster. So at the industry level only, if it happens, then it will be good. Like not using the blend of plastics because that are very difficult to recycle. So saving 77 to 120 EUR for each tons of plastic waste collected. Okay, so this is the last slide, I think. So we will be discussing more of this along with the questions. So I will be taking some questions and then we will be discussing. So now I will be just discussing the question, right? So there is this waste-free Ontario. So this is the strategy for a waste-free Ontario, where this building the circular economy they have, where to support a shift toward the circular economy. Ontario passed the Waste-Free Ontario Act, which is 2016. It enacted two acts: the Resource Recovery and the Circular Economy, and the another one is the Waste Diversion Transition. Under the new legislation, the province is moving toward a circular economy framework by establishing a producer responsibility regime, right? So let me just, so these are some of the changes, some of the zero waste predictions based on that for the Ontario. So these were the case study of Ontario, another case study of Unilever, right? So let us go for the question that we had. So before that, I will be discussing the problem that one student asked in the last class. So he was actually asking that is, sir, in one of the slide which was discussed in the week first, it has been told that PVC is at the level is having code 3, which is the third, and he was thinking that this resin identification code is based on the ease of recyclability. So he got confused, or there is some misinterpretation that this list is as per the ease of recyclability. It seems like, because this PET is easiest to recycle, and then SDPE. The, so if you think like that, the whichever is easily recycled, he thought that that is put given code 1. No, the thing is, he got confused here. It is in the 6th week of the lecture where this map is there. Here also the same PET, SDPE, PVC, LDPE, PP, and polystyrene is there. So if you see PET, SDPE, PVC, LDPE, polystyrene, PPP, and polystyrene is there. So if you see, he was thinking it is PVC is difficult to recycle, right? But still it is given code 3. It should be somewhere at the end, na? Why it is given 3? So that confusion, what I came across is the definition that I wanted to discuss is, let me just discuss that, then we will be actually going ahead. So the definition says, if you see here, the Resin Identification Code RIC is a numbering system developed by the Society of Plastic Industry SPI, okay, to classify different type of plastic resins, right? So let me just make the bullet points out of it. So here it consists of number 1 to 7, usually found inside a triangle of arrow uh, on plastic products. The code helps in identify the type of plastic, but it does not necessarily indicate the recyclability, right? This point has not been explained anywhere, so I will be actually highlighting this. Okay, so this code does not necessarily indicate the recyclability. There was the confusion. Here is what each code represents. Since the RIC, since the resin identification code, let me just allow if somebody joined. Yes, so this, where is this? Yes, let me just say. So this, the confusion was that this PVC is given 3 in the resin identification code, right? And here also it's 3, we understand, but it's given that it's very difficult to recycle, right? So his confusion was why this PVC is not given a code which is after 6, because he was having confusion that this is based on this ease of recyclability, but not. So it's just the classification. So each plastic type has been classified uh, by this Society of the Plastic Industry (SPI), where they have just numbered the system developed by this, and then this RIC primarily identifies the type of plastic. It does not guarantee that the plastic is widely recycled. For example, PET given 1 and HDPE given 2 and commonly recycled. Okay, whereas PVC 3 and the polystyrene 6 are more challenging to process, right? But still, the way it has been defined is actually not altering it. So if you see this here also, I have just given the it's difficult to recycle. Here you see it's difficult to recycle, but still it's given code 3. So that code is just one kind of classification. It does not give the ordering in this resin identification code. Okay, so the take home message is this: the the recycling code assigned to the plastic, which is the resin identification code, does not indicate how easily a plastic material can be recycled. Instead, it simply categorizes the type of plastic polymer. PVC is given the recycling code 3 because it is distinct polymer type, but it is difficult to recycle due to several reasons, right? So other things are there that why this PVC is difficult to recycle and so on. While PVC is marked with the recycling code 3, it is one of the least commonly recycled material due to their difficulties, right? So that was there. So now the first question that I want you to solve is this one. It's based on the last lecture, that last week content that was there. So you just type your answers in the chat box, and like we will be solving around 50 to 17 question today. I will see how much we can do. Okay, so let's just make it half. So it's done. So the first question is, which of the following is are the targets of the UK Plastic Pact for 2025? Okay, so here is this option A. 100% of the plastic packaging is to be a reusable, a recyclable, or compostable, right? 70% of the plastic packaging effectively recycle or reuse or composted. 30% of this average recycled content is this, and then another one is that one, right? So let me just see PRI. So let me just see if these are the one. Hmm. Hmm. Somebody is giving D. So others, please attempt. We will be discussing the answers also. So there is some. My my PC is stucking. So it's like some hang is there. Yes, now it's okay. Hmm. Yes, it's weekend one. So one person gave answer D. Others, please attempt. Which of the following is are the target of the UK Plastic Pact for 2025? Is this 100% of the plastic packaging is to be reusable, recyclable, and compostable? 70% of the plastic packaging effectively recyclable, compostable, and 30% of the plastic recycling content across all plastics, right? Somebody join, please. So the first question, you please attempt. So let's see the answer for the question 1. So answer to this is correct. The one that you have given is D, which is all of the above. So we will be looking at the detailed solution for that. If we see that, what is the UK Plastic Pact? It is here the UK Plastic Pact, of which this PAP signatory brings together the entire plastic value chain and has set various targets. So that was the targets that has been discussed here. 100% of the plastic packaging, 70% of the plastic packaging one, which is the option second, and third one is the average recycled content. This take actions to eliminate problematic or unnecessary single-use packaging items through redesigning, innovation, or alternative reuse delivery models, right? So they also had this zero plastic packaging to landfill, right? Let me just see if somebody. Yes. So this says this zero plastic packaging to landfill. All UK plastic packaging and single-use items are to be reused, recycled, and has to be recovered by 2030. They had this just had this estimate. Most leading brands and retailers have already committed to using only reusable, recyclable, or compostable packagings by 2025, and BPF is signatory of this PrEP UK Plastic Pact, right? So let us just see the next question. Let me just check that. Yes. So in this one, option D is correct, as so D option is correct. You please go for this second question. B option is correct, right? So these videos are being recorded and this will be shared to you also. So if this is last week, after this most probably one extra session will be there on this Friday, I think, same time 7 to 9. And in that mostly I will be discussing all the questions that has been discussed from this week 1 to 8 in this problem solving session, so that entire this revisit of all will happen. Along with that I will be going through some of the discussions or the important areas from where you may expect some questions in the certification exams, which is going to help. And the next question here is this: according to British Plastic Federation 2016, what are the recycling rate for this consumer plastic and aluminium consumer plastics and aluminium drinking bottles respectively? According to British Plastic Federation 2016, what are the recycling rates for consumer plastic and aluminium drinking bottles respectively? Please attempt this question. First option A is 70%, 74%. Option B is 74%, 70%. Option C is 37% and 70%. And option D is 70% and 37%. So please attempt this question. So option B is the attempt that you are giving. I will see. Rashid, please attempt. At least attempt. Then only you will be actually making mistake, and then there is possibility of correcting them at the end. So this course was more or less more theoretical, but at the same time it was awareness kind of course where you are actually learning lots of. It's like complete concentrated informations on plastic. So what I will tell about this course is like all the aspects, whether it is environmental, economical, social, as well as this lots of this sustainability uh, and overall related things or this interrelated areas of health related to this plastic. Overall, everything was taken together within a 8 week content. As many times I has told in the lectures that there is not a specific book that will be actually taking care of all the aspect that has been taught here. So lots of different materials have been discussed in overall different weeks. So this is interesting. So this has been recorded in 2018. Now 2025, lots of different other innovations and problems have been emerged in the society, and obviously there are some new solutions to the existing plastic problem. So this course is a bit dynamic, so it will be changing with the time. So there has to be different sessions of this plastic waste management 2.0 or something should come if possible to include the new changes that has been imparted, right, to the existing policies, and as well as the influence or impact of that thing, right? So let's see if this is right or wrong. Let me just project this. So the answer to second question is B. You are right, and the solution for that is this one. This is given by this British Plastic Federation, where this different recycling rate for the drinks containers has been given as shown here. So cartoon are the least one, and then consumer plastic drinks are the most one. So you see this extremes are mostly asked. So it's easy to actually have certain idea about that, right? So option B is correct. So B is correct, right? The next question is this one. I will be just expanding it. So yes. So which of the following is not an objective of circular economy? Option A is regenerate natural systems. Option B is design out waste and pollution from the system. Option C is dependence on non-renewable energy sources. And option D is build economic, natural and social capital. Which of the following is not an objective of circular economy? So HODC is saying 3, 1C, third C, they is saying dependence on the non-renewable energy sources. Uh, so that is not the objective. So we will be looking at, so I will just wait for some more time so that another person if he wants to attempt. Fourth D is saying, so I will be looking all the questions. So today at the end we will be discussing together like yeah, every one of you is from the this background of polymers or civil engineering, or like there is different uh, areas, or like everyone is students, or sometimes I saw some industry personnel or some other peoples also do this course in order to enhance their understanding of the same as well as interest to fulfill their interest, right? So which of the following is not an objective of circular economy? So fifth D. Oh God, I was mute, I think. So this which of the following is not an objective of circular economy? So we will be looking at the answers. So I think I was mute, so I was speaking something, right? So everyone is from this civil engineering or this environment background, or what is the background of yours? Rashid, HODC, sir. And now we will be looking at this answer for the same. Yes, so this answer to this is which of the following is not an objective? So option C is correct one. Yes, third C is correct one, sir. And this let me just put this. And solution for the same is here. The objectives of circular economy. The option the point one is this: design out waste and the pollution from the system. Okay, keep products and materials in use, regenerate natural systems, redefine growth and focus on positive social society wide benefits, gradually decouple economic activities from consumption of finite resources, and then transition of to renewable uh, energy sources, right? Build economic, natural, and social capital. That was the one of the option for the same, right? Which is D option, right? So option C is correct one, and option C is correct one. Next question was this: PRNs stands for packaging recovery norms, packaging reuse notes, packaging reuse norms, and then packaging recovery notes, right? So if you see this here, fourth D is attempted, and packaging recovery notes is the correct answer that he has attempted is D, and we will find that here in this one, which is this PRNs is standing for this packaging recovery notes. Okay, and are certificates of evidence that prove a tons of packaging waste has been recovered and reprocessed or exported, right? So PRNs and the packaging export recovery notes are issued by recyclers for and bought directly from them or via compliance schemes, right? They provide evidence of recovery or recycling and are substitute for business meetings their obligations through their own recycling efforts, right? So obligated brand retailers and manufacturers buy these uh, as part of their responsibilities as a producer, so which is a part of EPR, right? So the packaging recovery note PRN system was designed to help the United Kingdom achieve recycling targets set by the government, right? So so D is the correct answer. So mostly all the questions that HOD service HOD is actually the name which is there is giving correct. D is correct. Very good. So the fifth one is, why is the concept of circular economy significant? So option A is, helps in positioning the world to better address emerging resource security scarcity issue in the future. So B, helps to reduce the environmental impact of our production and consumption worldwide. And C is, helps in reducing waste, and D is all of the above. So the one that he has attempted is D, all of the above, where this circular economy is having all this, helps in reducing waste. That is the one thing that was there. So it is clear from the option itself. Help to reduce the environmental impact of our production and consumption worldwide, and this one. So the answer is correct again. So the fifth D is correct, and the solution for the same is here, where this why is circular economy important, where we had this uh, creating new opportunities for growth, a more circular economy, where this reduce waste, deliver greater resource productivity, deliver a more competitive economy, and then position the world to be better addressing emerging resource security scarcity issues in the future. And it will help to reduce the environmental impact of our production and consumption in the world, right? So now we will be going for the next question, which is sixth question. So this one is option D. D is correct. Okay. So we will be going for question number 6, right? So before that, it will be good if we just have some conversation. So like HOD sir Rashid. So can you tell about you, from like which college, or you are a student or personnel, or which department you are working, like doing your studies? So it's like last week.
Good evening, sir. Good evening, sir.
Good evening. Good evening.
Sir, actually, for sake of interest, I just attended this course.
Okay. Okay. Good.
So I am a 62-year woman.
Okay.
Okay,
Okay.
sir.
Okay. Thank you. I am a student, man. So I'm
Okay.
like I is currently doing my PhD in fourth year. I
Yeah.
just started. So like
Yeah.
as a part of our teaching assistants, we need to teach. Or sometimes, like last semester, I was teaching in a state government college here at Assam.
Yeah.
And this time I had this opportunity of teaching at NPTEL, so we need to do this. Thank you so much, man. Like it's my
Thank
privilege
you, sir.
to interact with you.
Yeah, thank you, sir. Thank you, sir.
Yes. So your background is, man?
Actually, I completed my BTech in 84.
Yes, man.
Then I did my post graduation in environmental engineering.
Yes, man.
Then I also got PhD in solid waste management.
Okay, so your entire area is around this thing only.
Yeah. So for sake of interest, I just attended this course.
Okay, ma'am. Actually, myself, I am actually I did my chemical engineering. I am chemical engineer, and I did my BTech and completed it in 2020, ma'am. And
Okay.
afterwards, I did my masters from here at IIT Guwahati,
Yeah.
and in this petrochemicals. So like it was a specialization in petrochemical sciences. And
Okay, sir.
then afterwards, I started doing my PhD at Center for Nanotechnology, and my work area is on micro nanoplastics.
Okay.
So,
Okay.
like as a part of that, also I had interest in going for this course, and at the same time, like this uh, plastic waste management is one thing, but when once these plastics are actually this particular slide, if I explain you, so like they whatever plastics that are there in the environment, if we see this plastic, because of the environmental action, and
Yeah.
because of aging, they are actually converting themselves into the microplastic and nanoplastic over the time. And also these tires, whenever brake is being applied or everything is happening, there is this attrition, or because of that attrition, lots of small chunks of plastics, which is a part of tire, which is rubber, is actually
Yeah.
getting left at the roads, and afterwards it is being washed by this water,
Yeah.
which is rain, and then it is floating in the air if the size of this particular chunk of the plastic is very small. Because if
Yeah.
something is in micron and nano, it will be actually like, it will be like dirt, or this
Yeah.
it will be floating in the air also, that we are actually breathing. So
Yeah.
whatever plastics, bottles, cloths, these are there, they convert themselves into these fibers, foams, fragments, and beads, and
Yeah.
gradually they are actually making their way into our food. If
Yeah.
somebody is
Food chain.
non-veg, then they are actually getting that, and
Yeah.
gradually it is entering our body and causing different kind of diseases. So
Yeah.
one of my PhD problem is this only, like what are the health
Okay.
implications of
Okay.
this micro nanoplastics, especially the nanoplastic.
Yeah.
So there are some reports that they are there in the body, they are there in this. These reports suggest that micro
Yeah.
nanoplastics are now there. They are in the lung, they are in the blood, they are
Yeah.
there in this mother's breast milk.
Yeah.
It is in the
Yeah.
placenta of the woman. So most
Yeah.
probably it is actually interacting with the newborn born baby. And like
Yeah.
there is just a recent report where there is a study on this mice. So they have reported that these plastics are making their way to the brain. So it is actually crossing the blood-brain barrier.
Okay.
So so in this one, what I am doing is some health implications are there. So in that, I am actually working on like in vitro systems I have created via cell culture and other stuffs to get some insights, like what is the toxicity and which kind of disease most probably will be happening at the end
Yeah.
because of uh, these micro and nanoplastics. And one of my objective is like, if this plastic is now this micro nanoplastic is not the problem. These plastics act as a vector for other pollutants. So
Yeah.
they are
So
actually,
oil
yes.
based, yeah, oil based. So the persistent type compounds get absorbed,
Yes,
right?
yes. So other toxic compounds are being absorbed, and now they are more dangerous as compared to
Yeah.
the pristine plastic micro and nano size
Yeah.
there. So that is the one that I am working on, and like this course is like the advanced version of this course will be what is the management methodologies for this micro nanoplastics.
Yeah.
That is
Yeah.
another thing. So thank you
Yeah.
so much, ma'am. Right.
Thank you, sir. Thank you. Thank you very much. Happy to interact with you.
Yes, I too, me too, ma'am. Now this the sixth question that is there is this one, which is this uh, which is the most preferred option in the waste management hierarchy. Option A is source reduction, and then this reuse. Option C is recycling, and this option D is disposal. Right. So please attempt. Which is the most preferred option in the waste management hierarchy? Option A is source reduction, option B is reuse, option C is recycling, and option D is disposal. So sixth A, I'm attempting. Now the seventh one also you can attempt, which is are the technical strategies for recovery and recycling of the PSW, right? Plastics. So option A is this improvements in size reduction technologies. Option B is this improvements in sorting technologies. Option C is this designing of products for recyclability, and option D is all of the above. So seventh D, ma'am, is attempting. So let us discuss the one. So some lag is there. Yes. So sixth one is, which of the following is most preferred one? Is the option D, which is this. Option A, which is the source reduction. So in this one, if you see this, the top most, this was the first slide of the week, I think first or second slide of the week, right? And there this discussion was there. This source reduction is the most preferred option for this waste management hierarchy. And 6A is correct one. A is correct, right? And then the seventh, which is are the technical strategies for recovery and recycling of PSW, right? So in this one, seventh D, she has attempted. So let me just see. Yes, which is are the technical strategies for this recovery of recycling, and here are those points: improvement in recycling technology and infrastructure. Where is this extrusion, blow molding, etc. These all has been discussed in this first week of the course. So what is a blow molding, what is this extrusion, you may go through some questions you may expect from here also. And then this improvement in the size reduction technologies, right? Improvement in the sorting technologies, and then designing of the product for recyclability and ensuring materials applicability in manufacturing processes, right? So option D, all of the above is the correct choice, all the same, right? So D is correct. Now we will be going for next two questions. So this is from the case study last second lecture and last lecture also, some part of that. So what interim goals does Ontario establish to mark its progress and keep on track with their strategy to achieve a circular economy? So A is this 30% diversion rate by 2020 and 50% diversion rate by 2030 and 80% diversion rate by 2050. So these are different diversion rate. Let me just see if he joined. So different diversion rates are there, and for the respective years and their percentage. So what interim goals does Ontario establish to mark its progress and keep on track with their strategy to achieve a circular economy? So eighth A, I has attempted. So these are all videos will be like PDF for this particular thing. Lecture and the video will be shared, and also the complete lectures, uh, problem sessions are being shared. So I will just, whomsoever is appearing for exams, it is good to once revisit all the questions that has been discussed for each weeks. Then that will be very helpful in actually revising the entire content that was there. So like both whatever assignments were given to you and whatever has been discussed here. So these mostly 30 to 40 question sets will be there, that will be actually reminding you of different topics that has been taken in different weeks, each half an hour session, in each hour, half an hour sessions, right? So you please attempt. 8th AMM has attempted. So what is the interim goal does Ontario establish to make mark its progress and keep on track with their strategy to achieve a circular economy, right? So we will be going for the answer. So if we see that it is correct one again, and here is this strategies that they have used for the to achieve a circular economy, where this Ontario 5 it must be take advantage of resource recovery and waste reduction as an economy driver and factors in environmental protection, building on our new foundation. The following outline Ontario strategy to achieve its transformation to the circular economy, right? So where their vision was, the vision for the Ontario is one where waste is seen as a resource that can be recovered, reused, and reintegrated to achieve a circular economy, right? And that is the main motive of circular economy. And if the and goal was this, the goal are to achieve zero waste Ontario and zero greenhouse gas emissions. So these 2 points become important where you can expect some question. So zero waste and zero greenhouse emission from the waste sector is the one which was the goal for this Ontario, right? And to make our progress and keep on track, we have set three interim goals, and these are the percentage for that for respective years, right? So this blue color shows the kind of, let me just see if things are 8A is as attempted. So A is correct one. So A is correct answer, right? And now, yes. So this slide we have discussed. So the next question is, which of the following is not an environmental strategy for recovery and recycling of plastic solid waste? A is enforcement of the producer's responsibility regulation to encourage collection of plastic waste. B is enforcement of nationwide law on plastic waste recycling. C is this transnational cooperation on waste plastic recycling. And D is enforcement of the waste segregation at the household level. So ninth C, transnational cooperation on waste plastic recycling. I was attempting. Let's see. We will be looking at the answers. So what I will encourage you all to, like, mostly look at the extremes from beginning, like revise all the slide if possible. Mostly you will, whatever you will be getting, which that will be from the slides, or only the questions that has been asked in the weekly assignment and the questions that is there in the problem solving session. So there were two problem solving session. One is from myself, and another one is from uh, the other student. So other other course member. So you may go through both the one. At least just keep your video at the pause and then just go through the questions and revisit all the slides. That will be helpful, right? So which of the following is not a environmental strategy? So ninth C, let us see. Ninth C. Yes, 9C is correct one. So translational cooperation on waste plastic recycling. So here is these recovery and recycling of plastic solid waste, PSWs. And if you see this, enforcement of producers responsibility regulation to encourage collection of the plastic waste, enforcement of this national wide law on plastic waste recycling, this legalization of selective collection performed by waste pickers from household retailers, dump sites, etc. Enforcement of this environmental awareness programs on importance of plastic waste recycling, enforcement of the waste segregation at the household level. So from there only, from the home only, you are actually dividing the sections for this plastic waste, then organic waste, and in the plastics also, if you can divide the plastics based on the code, right? So creation of the quality standards and certification schemes for this plastic recyclers, right? So then that will be a kind of reward and motivation for them to actually go for this. So Option C is correct one, right? So C is correct option. And the next one is this question number D, 10th question. And then afterwards we will be having some true false question. So which of the following acts does the Waste Free Ontario Act of 2016 enact? Option A is this Resource Recovery and Circular Economy Act 2016. Option B is the Waste Diversion Transition Act 2016. Option C is the Zero Waste Regulation. And option D is this waste, both A and B. So 10th D. Another attempted. Which of the following act does the Waste Free Ontario Act of 2016 enact? Okay, so let's see the answers. So yes, option D is correct one, and the answer to this is Waste Free Ontario Act is this one, and it is to support shift toward a circular economy. Ontario passed the Waste Free Ontario Act 2016, where they enacted two acts. First one is this resource recovery and the circular economy. I have just discussed it today only. While the beginning of the lecture, uh, the Waste Diversion Transition Act 2016, where they under the new legislation, the province is moved towards the circular economy framework by establishing a producer's responsibility regime, where they are actually the whole purpose is to go towards the circular economy, right? So D is correct one. D is correct. The next question, please attempt. State state whether the following statement is true or false. In circular economy, materials constantly flow in a open loop system where they are being used once and then discarded. False. B option is false. In circular economy, material constantly flow in open loop. So it's false now. There has to be circular, so it's closed loop where they are being used and discarded. So it's a direct question. So direct answer is there for this. So option B is correct one. It's a closed system. Okay. So the circular economy is restorative, regenerative by design. This means that the material constantly flow around a closed loop system rather than being used once and then discarded. As a result, the value of the material, including the plastic, is not lost by being thrown away, right? So in the case of plastic, this means simultaneously keeping the value of the plastic in the economy without leaking into natural environment. So everything natural environment like environment, ecosystem, society, and the overall purpose of this circular economy, which is the sustainability and maintaining the sustainability for the future, at the same time maintaining the needs of the present society. So false is the correct one. So B is correct answer. Now the next question is this one, question number 12, which says state whether the following statement is true or false. The major objective of the circular economy is to reduce the environmental impact of production and consumption system. So option A is true, option B is false. So here attempted this option A, which is true. So if there is nobody, so I will be actually moving fast now. Then we will be at the end, we will discuss some of the overall like summary of the course. So the next question is this one. Here this option A is correct one, and the solution to the same is, from the study, what was the conclusion? It is necessary to assess the environmental performance of current waste plastic packaging management as well as with respect to the increasing targets, right? So moving beyond mass-based indicators is needed by assessing the waste management system with respect to the environmental performance as well. After all, a major objective is of the circular to reduce the environmental impact of the production and consumption system. So this is the third point from where the question has been made. So 12th is correct. Is correct answer, right? The next question is this one. So I can put all this three big. The next question is 13th, that says state whether the following statement is true, false. Establishing service provider requirement to protect the environment while promoting resource recovery is an action proposed toward waste-free Ontario. 13th A is attempted that this is to establishing service provider requirement to protect the environment while promoting resource recovery is an action toward waste-free Ontario, right? Let us see the solution for the same. So the 13th is correct one. So these are some actions toward the waste-free Ontario, and here is the objective two, where this enable efficient and effective recovery systems. So this was this action 4, where transition existing waste diversion programs to new producer responsibility framework without disruption of service. Action 5 was amend the 3R regulations to increase resource recovery across all sectors, establish service provider requirement to protect the environment while promoting resource recovery, ensure landfills are well planned and managed. In India, there are very less landfills which are planned, by the way. So that is the one step that government could actually encourage. Let me just allow. So Prachi Kumari, I think. So this is like last question, establishing service provider requirement to protect the environment while promoting the resource. It's true one, right? And here this ensures landfills are well planned and managed to minimize this need to reduce greenhouse gases. And then establish promotion and education requirement to support public participation in resource recovery, which is the last three: resource recovery, and then this landfilling, and then this incineration. These three were the end management of the waste, right? So the next question is 14th one. This one is true. Right? It's true. Option A is correct. It's correct, right? 14th is state whether the following statement is true or false. So it's better product design helps in improving plastic recycling. A is true, B is false. So better product design helps in providing improving plastic recycling. It's true. So that was discussed na if the that was discussed in the lecture. If this I think if a product is made from this mostly thermoplastics, then that could be recycled easily. And if it is made from pure single material, it is not made from the blend polymers, then it is more easily recyclable. But if it is made from the blend one, then it becomes difficult. If it is from the thermosets, then it is having some kind of difficulties, right? So, so that is correct. Okay. So this one is true. So answer to this is, let me just open it. Yes. So answer to this is this. A. Correct answer is A. Better product design is A, and the solution to this is this one, where this better product design makes the plastic recycling easier, saving 77 to 120 EUR for each tons of plastic collected, right? So that is one thing. And the next question is, state whether the following statement is true or false. Increasing consumer awareness on it is the last question. So on plastic recycling is a societal strategy for recovering and recycling plastic solid waste PSW, right? It's true, it's false. State whether the following statement is true, false. Increasing consumers' awareness on the plastic recycling is social strategy for recovering and recycling plastic. It's true, no? So this was the last question for today's lecture. So this is the 8th week, by the way, the last question of the entire course. Yes, it is a where this societal strategies for this recovery and recycling of the plastic solid waste, where this use of the incentive schemes to motivate plastic recycling at the household level, efficiency of the municipality, private waste contractors, or informal waste collectors to in waste collection, introduction of the plastic waste segregation at the household level for recycling purpose, then increasing consumer awareness on this plastic recycling, education of this household community on this prevalence of environmental waste collectors in this supply chain. So overall, you see this. Uh, this is more of this make people aware, right? Okay, so this was it for the course. So I will be again going through some of the slides of the week or the other weeks that has been discussed. So hello ma'am. So like yes,
Yes, sir.
yes. I was saying like you are in this field of this environment, like
Yeah,
environment related stuff for a longer time. So what you
yeah.
feel like when you was there during your PhDs and that time of India, the kind of waste or the waste management strategies which were we followed, and now which is there, and the condition of our country now which is there. What changes do you see, or what could be the possible solutions to this problem? Because now India is more of developing, so lots of uh, wastes are also coming. So overall, out of this course, you are actually relating the things much better than anybody else. because other aspects are also there in your education, which will be actually clubbing up together to better understand this particular problem of plastic waste.
Yeah, people's minds should change. That's my opinion. Because
That is
they
the
should
first.
know how to, yeah, how to minimize the waste,
Yes,
how to use eco-friendly type materials. Like that, they have to change their mind.
yes, that is there. But this that was the last question, awareness. But but the
Yeah,
thing is,
that was the,
yes,
yeah, social awareness. Yes,
the-
that is required. Yeah,
so this could be one thing. Like lots of efforts should be put in order to make people aware first
yeah,
in this
yeah,
direction. Another one is
yeah,
like this. Even the people are aware most of the time.
yeah,
It's not coming in their habit.
yeah.
Every
Strict rules should be strictly enforced. That is another thing.
yes.
Yeah,
So the enforcement of the rule is not strictly
followed.
followed.
Yeah,
And overall,
that should be.
this the problem with this alternative materials are also there. Na? Like if
Yeah,
I
alternative materials are of course there, but whatever we are doing, whatever process we are doing, in fact, we are contributing some pollutants to the atmosphere, right?
is somewhere or other we are anyway giving that in every
Yeah,
steps that we are doing.
yeah. Optimal use of the material is required, actually.
So like right from the beginning, when a child is
Yeah,
getting educated,
yeah,
from there only that will if the change will happen what I expect then only it will be actually coming into the picture at the end. But most of the time childs learn from the parent,
yeah,
and if it
yeah,
is not being followed at that level only, then everything will be in the books and documents.
yeah,
Yes, and the thing is, I am usually most of the time going through the literature around this micro nanoplastics, this, that, those,
yeah,
everything.
yeah,
What I saw is that the bigger plastic that are visible to the eyes,
yeah.
that is
But
problematic.
this nano is not visible.
It's
Yes.
not visible, and currently, ma'am, it's very difficult to detect these plastics. So there are some
How you are
methods.
detecting, sir?
Uh,
My question is how you are
Yes,
detecting the
yes,
presence
that's
of
what.
this nanoplastic? Yeah,
That is the one thing that I'm saying. Ki
yeah,
these plastics now,
yeah,
there was this one slide I was having. Let me just.
yeah,
That was this slide was there. Let me just see if it is there. So it's like it is on YouTube. Some professor is giving some this talk on the same uh,
yeah,
plastic detection, right? And in that, what
yeah,
I observe is, uh, let me just see. Yes, this is there. When my slides are visible, right?
yeah,
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 yeah.
yeah,
This is by this Wen Zhang, an associate professor in the Department of Civil and Chemical Materials at this New Jersey
New Jersey.
Institute, and he is
Yeah,
having one session where he actually showed what still challenges us to detect microplastics and the nanoplastics in the environment, right, man? And there, na,
yeah, yeah,
he discussed lots of different methods which is there to detect the plastics. But the main
yeah,
problem with this is that if pure plastic is there, if only
yeah,
suppose polystyrene is small plastics, small size micro or nano polystyrene is there, right? Then
yeah,
then they are using lots of different costly analytical techniques, for
equipments.
example FTIR, Raman.
Yeah,
Using that they are
yeah,
detecting, but they
yeah,
currently in 2025 still there is no such device which is handheld, which is very small, that can be carried to the remote area, and that can detect
yeah,
the micro and the nanoplastic very efficiently in the complex samples. Because
yeah,
any plastics which is there, it is not the pristine plastics in the form of micro and nano. It is in the
mm,
environmental sample. Sometimes it is in the
yeah,
sewage waste, it is in the biological tissues, and it
yeah,
is at different places, and with the lots of extra different interferences. Sometimes these
mm,
interferences are covered because of the organics and everything. So
mm,
that are the current challenges of this detection of these plastics. So what we
Yeah.
know is this: anything below 5 mm is the microplastics, and
Microplastics.
anything
Right.
below 0.1
Point
micrometer
one
is the nanoplastics, right?
nanoplastic.
And in
Mm.
that, if we see that these size of the
Yeah.
nanoplastics are very much
Plastic.
comparable to the size of different entities which is there in the body and which is giving life to
Yeah.
us.
Yeah.
And if we see this plastic pollution and the threat to the ecosystem, what are the nanoplastic these are the techniques that are being used, ma'am. So there are different
Yeah. Yeah.
characterization techniques for currently they are using,
Yeah.
but the
Yeah.
the main problem with these techniques are like they are not incorporating the interference of different entities. So for the real sample, these methods will fail,
Yeah.
or if
Yeah.
they will succeed, there has to be lots of this pre-processing of the sample that we have collected. And
Okay.
another one
Okay.
is, if this plastic problem or the micro nanoplastic problem is happening at the ground level, in the villages, in the cities, at very remote places. So everywhere people cannot afford this very expensive instruments.
Yeah.
So it's like now in the healthcare, people need point of care testing, POCTs, so that they can go
Okay.
to the remote area and there only see whether the person is having this malaria or typhoid or not, very rapidly.
Mm.
Similarly,
Yeah.
there has to be a device which will be actually detecting the plastics in any sample, or it will be
Mm.
just say that yes, this is having polystyrene. There is first the detection of the plastic. Second is which type of plastic it is. So
Yes.
so in that lots of methods are there, ma'am. Like I will be just
Yeah.
prompting through that. Is this one? If you see, uh, uh, lots of these are the pre-treatment. If any this particular slide, if we see now here
Yeah.
here this plastic is there, they can be in the form of micro and the nano. So if it is
Yeah.
coming from the real complex samples, it has to
Yeah.
first go for the pre-treatment and separation. So you are
Okay.
actually in different steps. You are somewhere you are removing the inorganics, somewhere you are
Yeah.
removing the organics, somewhere you are
Mm.
removing some other kind of biological entities or the materials which is there, metal ions, they are there, so that the
Mm.
finally whatever sample you are having is mostly plastic, and then you are going for the quantification.
Yeah.
So in that, the only single article is there. This is a review article, I think, where this very less papers are there, where they have actually took the complex sample and they
Yeah.
had lots of pre-processing steps. Finally, they detected that yes, there is the plastic. So currently, the analysis methods that are there is this. You can visualize that in the microscopes
Yeah.
if they are in the micro size, and if they are in the nanometer size, they can be visualized through this scanning electron
Yeah.
microscopy and transmission electron microscopy, right?
Yeah.
But if this in plastic is spatial structure, so if they are in the biological sample,
Yeah.
so looking at the biological sample, if somebody is purchasing some meat or, for example, species, there at the shop, they cannot see that whether my fish is having plastic or not. So,
Yeah.
and also they are just coming, getting it, and just cooking that. So
Yeah.
even currently one article I came across, you can just show that article. Uh, uh, there these whatever edible plants are there, na ma'am. In that also
Yeah.
these micro nanoplastics are making their way. So like some
Yeah.
some edible plants are there, vegetables are there. So
Uh-huh.
at the leaf of those plants, these
Yeah.
plastics gets absorbed. And whenever
Yeah.
our mother they have
Took
vegetables,
that.
they will just cut
Yeah.
that and they will just cook that.
Mm.
Most probably they
Yeah.
will just wash that with somewhat warm water, lukewarm water. But that
Yeah.
much cleaning will is not sufficient to actually remove the plastics which is
Plastic.
staying at the
Yeah.
surface. So there was
Yeah.
this study. Let
Yeah.
me just put that here. Yes, this plastic plant, micro nanoplastics. very small paper was there. So I can see that images. So yes, this one. Let me get more closer.
How it is get into the leaves?
Actually, from the air, ma'am. Like from
Okay,
the
okay,
it
okay.
is there in the environment.
It's from the air only.
So like
Okay. So I read one article
yes, ma'am.
in that the even this rainwater also it is containing these
Yes, it
microplastics.
will be containing because everything, whatever waste, plastic waste is there, it is there in the environment. Na? So like
Yeah, in
like
the
you may have seen that our chairs, plastic chairs that we are having, just
yeah,
after 1 or 2 years, the handles of the plastic chair will be leaving some of the plastics, small chunks of the
yeah,
plastic coming out from the handles. Why? Because
yeah,
there
yeah,
is this small attrition every time whenever we are actually using
yeah,
this or anything,
yeah,
any utensil
yeah,
or anything made up of plastics. With the time, they actually lose their the upper layer of that plastic lose their physical property or the mechanical
yeah,
property, and because of which there is some aberration happening
yeah,
or entire paints that we are having. We
yeah,
usually have painting of our houses. These paints are nothing but the epoxy and different resins and sometimes the
yeah,
different
yeah,
polymer blends. And every
yeah,
2 or 3 years, we need the our home to be painted, whether it is
yeah,
interior part of the house or the exterior part of the house. And whatever is
yeah,
exterior, every time because of the rain, it is being washed, and that
yeah,
washing is actually putting that small micro nano chunks of the paint into the water,
yeah,
soil, air around us. And
yeah.
and this
So any particular treatment is there to remove as such plastics from drinking water, because this conventional treatments will not be removing the plastic,
yes, yes,
right?
ma'am. Like in this wastewater treatment plants now, like there is some encouragement
Membrane
because
technique is
yes,
there.
there has to be like at the end they are trying to have these ultra filtration systems. So ultra
Oh
filtration
yeah,
membranes, those can actually is at
costlier, na?
to some extent they can actually solve this problem, but the problem is like they are very costly.
Ah yeah, very
So
costly.
that has to be cost effective only in order to actually have overall implementation of the thing. And this
Yeah,
micro nanoplastic problem is like just few days back I was reading some papers, and like they are the one now getting connected with the cancer problem. Like this
yeah,
northeast, you may have heard
yeah,
that
yeah.
in Assam and in some part of India,
Meghalaya.
there is this more
Yeah,
cancer patients coming up. And the
yeah, yeah,
problem, in that study, they have just spoke about that this micro nanoplastic could be the
yeah,
one of the reasons. So
yeah,
this paper discussed about that these plastics are there at the leaf, and they are also somewhere taking part in this cellular mechanism taking place in these plants also.
oh,
In
okay,
our body
okay,
also, through the food,
okay.
plastic is making their way to the blood. It
Blood,
means
yeah,
it is actually following the path of nutrient absorption from the food.
yeah,
So there are different universities or researchers working on in this area currently. But the thing
yeah,
is, whomsoever is giving solution, that solution is not of like globally implementable.
yeah,
And coming to the point that I was discussing, these are these different methods. So let me
yeah,
just
for detection.
yes. So pre-treatment has to be there. So you are actually
There.
removing different organics using
Yeah,
different things, and then you need to separate them. There has to be separation technique, and then the different separation technique. This is integration of two methods. You see, they
yeah,
have used this atomic force microscopy and also
yeah,
this optical and the fluorescence. So these are this visualization techniques, optical
yeah.
fluorescence and this SEM and TEM. And another one is
Yeah.
this surface morphology you are going to get through this AFM,
Okay,
atomic
okay,
force microscopy. And then
okay.
this material characterization using FTIR Raman, and now currently this is the most effective method which is currently being used. It is dark field
Field
hyperspectral imaging.
perspective
So this
imaging.
one, ma'am, just I think just 1 year back, this came into the picture, and this method is
Okay.
capable of tracking the these plastics from very complex matrices also, from the biological samples, from the food.
Okay.
In the food also,
Yeah.
it can track. So one
Yeah.
company has entirely built their own microscope. In that microscope, they are having this hyperspectral imaging clubbed with this FTIR.
Yeah.
So at the same time, they are actually looking at this uh, plastics, mm, dark field, so this plastics also which plastic. So they are tracking this,
Yeah.
yes, this,
Type of
yes,
plastic.
type
Yeah.
of plastics, and then quantity of the plastic and the zone where.
How will you, sir? How will you interpret the results?
So that particular slide I am not having right now. One video I have watched somewhere. So
Okay.
this
Okay. Okay.
dark field hyper spectral imaging. Let me just see if I can find that website. Dark
Okay.
field hyper spectral imaging. Wait. Dark field hyper spectral. Anyway, this part is being recorded, so everybody will be getting benefited out of that. It is related to
Okay.
the
Okay. Okay.
topic of the
Okay.
imaging
Yeah.
of for micro. Yes, so this polymers. There are some papers you see they have identified
Yeah.
in vivo in uh, this. Let me just see that company I can get. So like different complex matrices they are actually looking at.
Yeah.
Mm, dark field. So this is that setup.
Yeah.
Yeah,
Okay.
yeah.
Okay.
Cyto Viva.
Yeah.
Cyto Viva is the company. Let me go.
Okay.
This is
Okay.
the setup. Yes,
Ah.
this is the
Yes.
setup here. This you see, this is the
Yeah.
microscope where you will be
Yeah.
actually accept necessary. Yes, this is the microscope. It is having this hyper spectral imaging setup held, and along with that, they are having inbuilt FTIR. So
Yeah.
here this is the suppose your complex matrix is there, some biological,
Yeah.
suppose it is a tissue coming from the fish body,
Yeah.
and in
Yeah.
that you are looking at whether the plastic is there or not.
Yes.
So it will look
Okay.
like this, and these red
Yeah.
zones which are there, this will be showing which plastic is there. So suppose this
Type
is
of
red
plastic.
zone, so there will
Yeah.
be red colored spectra coming. So this is FTIR
Okay. Okay.
spectra. It will be giving the
Yeah. Yeah.
characteristic peak, giving the
Okay.
whether this is having which kind of tissue background, and then AU and P in the tissue. So different. Here they
Yeah.
have opted for the gold. If it is having plastic, then plastic can also be mapped.
Yeah.
So this is the most effective technique for the complex samples for right now, but it is again very costly.
Yeah.
So only few places they can actually purchase this and use that. But
Yeah. Okay.
this problem is of everyone. So
Yeah.
if some method or some device people can keep at home, like currently now people can measure their glucose at home only
Yeah.
using different devices. So that kind of development it happens and will be very
Hmm.
helpful in actually tracking the plastic. And
Yeah.
I think so. This was the one information that I wanted to share you. And
Yeah. Thank you, sir.
and
Thank you.
now
Thank you.
these are the other analytical techniques. Like here, they have combined this in the optical image. It will look like this, right?
Like this.
And
Yeah. Yeah.
in the FSM, you will be having entire picture, exact picture. And
Okay.
they have
Okay.
just
Okay.
had this Raman mapping. Through the Raman
Yeah.
mapping, they have mapped that this particular zone
Yeah.
is green and this particular zone
Yeah.
is red. Means this is
That.
suppose this is polyethylene and this is
Another one.
there is this combined Raman agglomeration of polyethylene. So another one is
Poly.
polyethylene and another one is something else. And what is
Yeah.
this? That can also be bad because the Raman is integrated in there. So Raman is
Okay.
actually giving peak for each sections.
Okay.
And vibrational peaks will be integrated together in order to get the
Okay.
exact this is spectroscopic information of like bond structure of the material. And
Yeah.
now there is this another this dark field hyperspectra that I was talking. Suppose
Yeah.
this is cell, so different zones are there, and then yellow part is there. So you will be getting different peaks.
Yeah.
So Cytiva, that company is actually working on that. And
Yeah. Yeah. Yeah.
now another methods are there where you are actually using this fluorescence. So you are tagging
Yeah.
your plastics with some kind of dye and then you are tracking in the microscope. So that is another thing.
Mm-hmm.
So people have this
Okay.
combined this laser scanning confocal microscopy, which is fluorescent visualization. And then
Yeah.
there are different. So these all the methods are very costly.
Okay.
And TIR Raman also tagging time. Now there is something called surface enhanced Raman scattering. So this
Okay.
is SURS means surface
Yeah.
enhanced Raman scattering. So like
Yeah.
if it is the surface of gold, if the
Yeah.
surface is of gold, platinum, and silver,
Yeah.
these three material only, these are the noble materials, and if these
Yeah.
metals are deposited here, so
Yeah.
this metal shows a property which is called surface enhanced Raman scattering. So if
Yeah.
your plastic suppose if on the glass, if you are having a plastic and you detect, then you
Yeah.
will get a Raman peak.
Yeah.
Raman peak intensity, maximum intensity, suppose for this particular peak you are getting 40, right?
Yeah.
Lekin
Yeah.
if this same plastic is resting on a gold substrate, its base
Yeah.
is gold, and now you are doing
Yeah.
Raman up, this 40 will
Yeah.
be suppose 400. So
Okay.
that peak will be getting enhanced by the factor of
Yeah.
100 or more. So
Yeah.
this is called Raman surface enhanced Raman scattering because surface which is of gold, silver or platinum, it is helping you to enhance the signal of a particular component which is the plastic. So
Okay.
currently people are also using this surface enhanced Raman scattering only to detect, especially the nanoplastics.
Yeah.
Microplastic you can anyway see in the microscopes and visualize through the fluorescence or anything. But these
Yeah.
nanoplastics are even problematic. If something is below 5 nanometer, then it is very difficult to visualize them.
Very detective. Yeah.
So in that case, people are using this Raman, especially the surface enhanced Raman
Yeah.
scattering. But the problem with this is there has should not be any interference
Yeah.
again. So that interference
Yeah.
is the one that has to be taken into account. So these were
Okay.
some different methods. AFM to with the AFM meters, deep enhanced Raman scattering is being used. Some are using this AFM kind of thing where this they are using something called this Kelvin probe microscopy.
Yeah.
So different methods are there, but these are very difficult to implement at the ground level.
Yeah.
So this was it for this particular uh, session, ma'am. And
Yeah.
hope this lecture gave you some insights on
Yeah. Yes, sir. Sure, sir. Sure, sir. Yes, sir. Thank you very
thank you
much.
so much, and it's again learning experience for me. I was
Yeah.
thinking student is on another side. Mostly students
Yeah.
when they speak.
Yeah.
Okay, ma'am. Thank you.
Okay,
Thank
sir.
you so
Thank
much.
you. Thank you
Thank
very
you so
much. Thank
much.
you.